Guys, welcome to my channel Boss with MXN. Today we are going to discuss a very important topic that is Proxy ARP. What it is, what are the use cases. If you're not familiar, this is the best video for you where we will explain what the Proxy ARP basically is and what are the use cases of Proxy ARP, advantages as well as disadvantages. Also, we're going to understand Proxy ARP with the help of a fine example. So let's get started. Proxy ARP. What is Proxy ARP? Proxy ARP stands for Proxy Address Resolution Protocol. It basically helps. You must be aware about the address resolution protocol. It's basically a subtype of ARP. There are various subtypes like inverse ARP, gracious ARP, proxy ARP, and many more. So this is a subtype of ARP. It's basically what it does. What it stands for is basically it stands for proxy address resolution protocol. ARP, you must be aware that what it does, it basically helps in mapping the IP addresses to the corresponding MAC addresses. If you want to, for example, this is my laptop. I want to reach out to you over your or maybe some other device over inside my network. My laptop is connected to another switch, and that switch is connected to another host. So I want to reach that host. What I do is I need the IP address of that host. Once I have that IP address, I'll send an ARP request over the network to the switch. What the switch will does, it will broadcast that ARP request, uh, and whichever host will have the particular IP, it will unicast that yes, I am the one, and this is my MAC address. Once I have the MAC address of the destination host, I will be able to send the traffic to that. So that was what ARP does. So talking about the proxy ARP, it stands for Proxy Address Resolution Protocol. Proxy ARP basically helps machines on a subnet to reach remote subnets without the need to configure routing on a default gateway. So, so for example, you want to route or you want to reach a particular host which is outside the subnet, which is basically on a different network altogether. Uh, so to reach that, you would basically need the all the address details of that particular host. So in that case, as it is on a different network, ARP would not be generated. ARP is basically address resolution protocol is basically sent for the devices that are on a particular subnet, on the same subnet or on the same network. So in order to reach that, what we do if the routing is not configured. If the routing is configured, then the router would have the details in its routing table and it will easily route the traffic to the particular destination. But if the routing table is not configured, how will we be able to communicate with that host which is outside on a different network? So in that case, if the routing is not configured on the default gateway, we make use of proxy ARP to reach that host. So proxy ARP is a technique in which one host, usually a router, answers the ARP request intended for another machine. So what proxy ARP does is, for example, you're sending a request to reach a host. For example, you are in you are in a network, and your device idly thinks that the host that you want to reach is in the same subnet as well, but it is not. Let's assume it is not. What it does is if proxy ARP is configured on the router interface, it will basically respond back to the ARP request with its own MAC address. It's a proxy basically. So the router responds back to the host, which is sending the request with its own MAC address. And the host basically thinks that this is the MAC address of the intended destination that I wanted to reach. So proxy ARP works in this way. It's like you are in a college and you are not present in the class. What you say to your friend is that whenever the attendants go by, whenever they call my name, you raise your hand and call out present. So what it does, it basically uh, makes an attendance on your behalf. So this is something exactly what the router in this case does. It basically responds to the request on the behalf of the end host that the machine wants to reach. Okay, if you fake its identity, the router accepts responsibility for routing the packet to the real destination. So once the router basically responds back to the host which is initially sending the request, it accepts the responsibility that it will route the packet to the real destination, because if it feels that it has the location embedded in its routing table, if it's present in its routing table, it will be able to reach that particular destination. So it responds back to the ARP request with its own MAC address, and then later on it will route the packet to the real destination by itself. Proxy ARP can help machines on a subnet reach remote subnets without the need to configure routing on a default gateway. So as I told it earlier, Proxy ARP, what it does, it basically helps a machine uh, which are basically situated on a different, which are basically two machines that are separated, that are situated on different subnets, reach each other without configuring the routing on the router. So this is used in case the routing is not configured on the router and you want to reach from one machine to another over that are basically segregated or separated on, or basically placed in a different network altogether or in a different subnets. So let's understand proxy ARP with the help of an example that will make it clear. The example is a little lengthy, but bear with me. You, by the end of the example, you would be able to understand the proxy ARP in a better way. So how does Proxy ARP work? Firstly, I want you to look at the network diagram that is mentioned, that is placed on the right-hand side of the presentation. Uh, there is host A, host B, host C, and host D. From host A is basically present in subnet A, and host C and D are basically present on subnet B. There is an Ethernet interface E0 on the router side and E1 on the subnet B side. There's also another host, and I want you to basically look at the subnet masks of the IP addresses that is configured on host A, B, C, and D. Look at the subnet mask, that is /16 for host A, /24 for host B, /24 /24 for host C and D. So host B, and look at the IP addresses as well. It's 172.16.10.100 for host A, 172.16.10.200 for host B. When you look at the IP addresses and the subnet masks, what you see is that host A is basically of the part of a network that is 172.16.0.0, because it's having a subnet mask of 16. That is, it is part of class B address. So whatever addresses are basically similar to it, whichever correspond to the host, the network ID of 172.16.0.0, it will think that is those addresses or those hosts are basically present on the same subnet. Similarly, from with host C and D, they are present on /24 subnet. That is, it's a class, they are subnetted in class C network. And look at it, basically they are having a different network altogether. It's 172.16.20.100 and 172.16.20.100. And host B also is on a different network, that is 162.172.16.10.200. Also, just look at these MAC addresses and just familiarize yourself with them. So looking at the example itself, the example below that is showing the how the working of proxy ARP basically takes place. Let's assume that host A wants to communicate with host D. Okay, host A is in subnet A. Just I'll use my marker to make it more clear. Just a second, bear with me. Okay, I hope you're able to see it. So host A is trying to communicate with host D that is present on subnet B. And look at host A, it's present on subnet A. You must be able to see it. And it wants to communicate basically with host D. The host D is present in subnet B. The IP address for host A is 172.16.10.100/16. And the IP address for host D is 172.16.20.200/24. What is the familiarity? Well, looking at the IP address, it is a part of network 172.16.0.0. So whichever IP address are basically in its network, it will assume that the host basically that or the destination that it wants to reach is basically present in the same network, because it is 172.16.20.200. So it will assume that host D is basically present in the same network that host subnet A that the host A is present in. Host A 172.16.10.100 with subnet mask 16 considers directly connected to this network as already stated. When host A needs to communicate with directly connected devices. So whenever the host wants to communicate with directly connected devices, what it does, it basically sends the ARP request. So in this case as well, host A, what it will do, it will send the ARP request to the destination, that is host D. In order to reach the host D, host A needs the MAC address of host D. So, you have got the destination IP that you want to reach, but to reach the device, you need this MAC address as well, that is 36.dd. So how will you get it? That's how the reverse proxy ARP will help us to get the MAC address of the host. So therefore, the host A broadcasts the ARP request on subnet A as shown. This is the table that is showing the sender's MAC address. That is host A's MAC address 36.AA. It is the sender MAC address, that is host A. The IP address of the sender, that is 10 ending with 10.100. It is the IP address of host A. What is the target MAC address? It does not know the target MAC address. So what it will replace the MAC address with all zeros. When it does not know the MAC address, it will replace the MAC address, target MAC address with all zeros. And what is the target IP address? It is the target IP address is the that of host D that it wants to reach. It's 20.200. Same. I hope you get this. Are you able to communicate? Are you able to understand till now? So moving ahead, in the same example, in this ARP request that is sent from host A, request that the host D sends its MAC address. So once the ARP is generated from host A, what it will do, it will reach the what it wants basically is that it wants the MAC address of host D so that it can communicate with it. Simple. The ARP request packet contains MAC addresses of host A as source address and destination addresses of all Fs. Okay. So destination addresses of all Fs. The ARP request, let's understand it in a better way. The ARP request packet sends contains MAC addresses of host A. Okay, so it is containing the MAC addresses of host A as source address and the destination addresses of all Fs. Since ARP request is a broadcast, it reaches to all the nodes on subset A, including router interfaces E0, but does not reach the host D. So when the ARP request is broadcasters, it will reach all nodes. It will reach host B as well as the router interface E0. But it won't be able to bypass the router as the router does not basically broadcast the broadcast traffic from the ARP. So it won't be able to reach the intended destination, that is host D. It will just reach host B as well as the interface E0 on the router. The broadcast does not reach the host D because routers do not by default do not broadcast the addresses. It's the same table that I had showed in the previous diagram. Moving ahead, since the router knows the target address, it is knowing the target address. A router knows because it is present in its routing table already. It has the routing table mapped for host D 20.200 in its MAC address table, which is in a different subnet. It is a subnet B. So it replies with its own MAC address to the host A. So what it does when it receives the ARP request from host A, instead of forwarding the packet to host D, what the router does is basically it responds back to with its own MAC address, that is 36AB. So it will respond that this is you have reached the destination and this I am the host containing the IP address of 20.200 and this is my MAC address 36AB. It will respond back. So this is a table that will make it more clear. What is the sender MAC address? It will be the MAC address of the router this time because the ARP request has already been generated. This is the ARP reply that the router is sending. Sorry. So 36AB will be the sender MAC addresses this time because this is the ARP reply, proxy ARP reply. So the sender IP address will be the IP address of the interface Ethernet, the Ethernet E0 router interface Ethernet 10.99. Okay. So it will basically what it will do is basically it will replace its IP addresses with the sender MAC address for the destination MAC addresses because this won't change. Only the MAC address basically changes and not it will not respond back with its IP. Basically the table that contains the IP address will not contain the IP address of the Ethernet interface on of the router, but it will just keep the destination IP as same this time, keeping it as the sender IP, that is 20.200 that is present in this table, and the target MAC would be and the target IP address would be that of the host A, that is 10.100 for the IP and 36AA for the MAC address. So this is the proxy ARP reply that the router sends to host A. Understood? So the proxy ARP reply contains the MAC addresses of the router as the source address and the MAC address of the host A as the destination address. ARP replies are always unicast. So what it does is the proxy ARP reply contains the MAC address of the router. As stated already, this is the MAC address that it will contain, that is 36AB in this proxy ARP reply. And the destination would be, what would be the destination? Destination would be the MAC address of host A, that is 36A, present in this table. Understood? So upon receiving the ARP reply from the router, once the host A receives the reply from the router, host A updates its ARP table. So whenever this time it wants to send or it wants to reach out to this IP address 20.200, that is the IP address of host D, what it will do is basically it will just forward the traffic to the router interface E0 containing MAC address 36AB. Okay, so whenever it wants to share the traffic or whatever it wants to send the traffic to host D or in the subnet B, what it will do, it will just forward the traffic to the Ethernet interface, the interface E0 of the router. So it just updates its MAC address table and maps it with the IP address. From now on, the host A will forward all the packets to 172.16, forward all the packets for whichever the packets it needs to send to 20.200, that is the host D, with the MAC address this. It will just shoot this to the MAC address 36AB, that is the MAC address of the router interface. Since router has the route to host D, it will forward the packet to host D, because the router will contain the address of the basically the route to host D. It will just forward the packet once it receives it from the host A. And the ARP cache on the host in subnet A will be populated with the MAC address of the router for all the hosts on the subnet. So in this table, you will be able to see that there are various various IP addresses present in this table, and they are mapped to the single MAC address, that is the MAC address of the router's interface. Okay, so what it does is basically whichever traffic is flown or whichever traffic comes from subnet A and wants to reach out to subnet B, what it will do is basically it will send all the traffic to the same Ethernet, the router interface E0 with the MAC address 36AB, and you see that all the different IP addresses on MAC are basically mapped with the same MAC address here. So whenever you see such a situation, you come to a realization that the proxy ARP basically is in use. Hence, all the packet destined for subnet B are sent to the router. The router then forwards these packets to the host in subnet B. Understood? So lastly, as multiple IP addresses are mapped to the single MAC address table, single MAC address, the MAC addresses of this router, which indicates that the proxy ARP is in use. Okay, so whenever the multiple IP addresses are mapped with a single MAC address, this basically shows that the the proxy ARP is basically in use. So how to enable this proxy ARP? You make the use of this command, IP proxy space /ARP command is used in the command line throttle. By default, proxy ARP is disabled. It is not enabled on the router interfaces. It is basically disabled so that it won't cause any security hazard or network problems. So it is basically disabled. If you want to enable it, you can go ahead and basically enter this command in the command line interface and it will be enabled. So talking about the advantages of proxy ARP, what are the advantages? Why is it basically used? The main advantage of proxy ARP is that it can be added to a single router on a network and does not disturb the routing tables of the other routers on the network. Understood? Pretty easy. Proxy ARP must be used on a network where IP hosts are not configured with a default gateway or do not have any routing intelligence. So if the default gateway is not configured and there is no routing table intelligence, this proxy ARP will be used. And disadvantages, or what are the disadvantages of proxy ARP? Basically, it just have an understanding first. Hosts have no idea of the physical details of the network, and it assumes that it's a flat network in which they can reach to any destination if they send an ARP request. So in this proxy ARP, it basically has no other hosts have no idea of the physical details of the networks, and what they assume is that they can reach any destination whenever they uh, basically shoot an ARP request. It basically increases the amount of ARP traffic on your segment. If they want to reach any network, they just shoot an ARP request, and they will basically, what that will do is basically that will increase the ARP traffic on your segment, on your network segment. Host need larger ARP tables in order to handle IP to MAC address mappings. So every host sending the ARP request and mapping IP to the MAC address table, it will basically increase the MAC address table length, which is quite hazardous. Security can be undermined. A machine can claim to be another in order to intercept the packets, and acts an act called spoofing. So it is a security threat as well. That's why it is disabled in the first place. Because any other machine can basically, if the proxy ARP is enabled, any other machine can intend or basically see basically have the intention that I am the one, that the machine that you're trying to reach, I am the one showing this MAC address, this is my MAC address, and you can reach out to me. But it can be some other third-party machine present in the traffic. So that is why this is basically disabled in the first place. It does not work for networks that do not use ARP for address resolution. So this was the advantages and disadvantages of ARP request. I hope you were able to grasp most of the information. If the information that was provided in this video was a little overwhelming, I would request you to go through this video once again, so to have a better understanding of the concept. And this was all about the ARP with an example and advantages and disadvantages, also what the ARP is in general. I hope you were able to understand it in a better way. And thank you for watching. Have a good day. Bye bye.